The following question is from the chemistry paper Eastern Cape, September 2023, and I need to explain question 616. Now the reaction involved is sulfur trioxide. 2 moles of sulfur trioxide forms 2 moles of sulfur dioxide and 1 mole of oxygen. So the mole ratio is 2 moles to 2 moles to 1 mole. So on the reactant side, you have a total of 2 moles going to, on the product side, a total gas volume of 3 moles. Now in the question they explain that they're increasing the pressure by decreasing the volume. So an increase in pressure by decreasing volume, if volume is decreased, then concentration will increase, because concentration is inversely proportional to volume. That means that both the forward and the reverse reactions will speed up because of the increase in the concentration. Concentration is inversely proportional to volume. But the reaction that will be favored by an increase in pressure is the reaction that will produce less moles of gas. So the reaction that produces less moles of gas is the reverse reaction. The reverse reaction takes 3 moles of gas and makes 2 moles of gas. That will have the effect, according to Le Chatelier's principle, to decrease the pressure again. So an increase in pressure will favor the reaction that produces less moles, and in this case it is the reverse reaction. So the reverse reaction will speed up more than the forward reaction. This solid line represents the forward reaction, and after some time the reverse reaction and the forward reaction will reach a new equilibrium at a higher rate because the volume of the container is made smaller. That explains question 6.1.6. The next question we need to explain is question 6.2. Right, they say that carbon and carbon dioxide are mixed in an empty 2 cubic decimeter container, which is then sealed off. The following balanced equation represents the reaction that reaches equilibrium in the container at 700 degrees Celsius. So the reaction is a solid carbon reacting with carbon dioxide gas to form 2 moles of carbon monoxide gas. Gas. At equilibrium, it is found that the concentration of the carbon dioxide is 0.05. So we have the mole ratio, we have the start, we have the what is used or formed, and we have at equilibrium, and we have the equilibrium concentrations. Okay, and we have the volume of the container is 2 cubic decimeters. At equilibrium, it is found that the concentration of carbon dioxide is 0.05 mole per cubic decimeter, and 0.4 moles of carbon solid is at equilibrium. So at equilibrium, the mole of carbon is 0.4 moles. Now carbon is a solid, so carbon will not be part of the equilibrium constant. The equilibrium constant for this reaction at 700 degrees Celsius is 0.05. So they tell us that Kc is 0.05. Now the expression for Kc in this case is the concentration of CO squared divided by the concentration of CO2. Now the concentration of CO2 at equilibrium is given, and the Kc value is given. So we can use that to calculate the concentration of carbon monoxide at equilibrium. And this is 0.05. So the concentration of carbon monoxide squared is 0.05 squared, because it's 0.05 times 0.05. That means that the concentration of carbon monoxide is 0.05 mole per cubic decimeter at equilibrium, 0.05 mole per cubic decimeter. Obviously we won't have a concentration of carbon as it is a solid. So to work back from concentration to mole, it means that the 0.05 must be multiplied by 2, and you'll get 0.1 mole. 0.05 times 2 is 0.1. So 0.1 mole of carbon monoxide was formed, because that's the mole at equilibrium. 0.01 mole was formed. How much of the carbon dioxide would be used? The ratio, the mole ratio, is 1 to 1 to 2. To work out the ratio, we go and we divide 0.1, my humble apology, 0.1 we divide it by 2, and we'll get 0.05 again. I feel like a dog chasing my own tail here. And what will be used from the carbon? 0.05 mole would be used. So if this is the mole at equilibrium, that's the mole that was used. What is the original amount of carbon that we started off with? 0.45 moles. It would be the mole carbon that was started off with in this reaction. I just need to read the question again. Carbon and carbon monoxide are mixed in an empty 2 cubic decimeter container. The following balanced equation represents the reaction that reaches equilibrium. At equilibrium, it is found that that was the concentration of carbon dioxide and 0.4 moles of carbon were present. Calculate the percentage of the carbon that reacted. So 0.05 is the carbon that reacted, and we started off with 0.45. So the percentage of the carbon that reacted would be 0.05 out of 0.45. 0.45%, and it works out something to 11 point something, 11.11. So it's 0.05 divided by 0.45%, 11.11% of the carbon reactant. That was a challenging question.